The polar bond in HCl causes the molecule as a whole to have opposite charges at either end. HCl is said to be a polar molecule. The HCl molecule on the whole is also a dipole. The extent of its polarity is expressed quantitatively by its dipole moment, which is found by multiplying the amount of charge on either end by the distance between the charges. Look at a molecule of BeCl2. There are two BeCl bonds present. The molecule of BeCl2 is linear. Drag the related arrows up to indicate the polarity of each of the bonds present. The two dipole moments in BeCl2 are equal in magnitude. Since beryllium chloride molecule is linear, the two equal dipoles point in opposite directions and thus cancel each other exactly. There is no net dipole, and the molecule of BeCl2 is said to be nonpolar. Click Next to try another molecule, H2O. Click on the box that shows the correct polarity of the bonds in the molecule. The two dipoles do not cancel each other out completely. Explain. Answer. The water molecule is bent, so the two dipoles are not pointing in opposite directions. The overall dipole of the molecule is also called its net dipole. Click on the arrow that shows the correct net dipole of the H2O molecule. For molecules containing more than two atoms, the net dipole of the molecule depends on the geometry of the molecule as well. Is there a net dipole? Click on the Yes or No button to submit your answer. Is there a net dipole for NH3? Select Yes or No option button to find out. Is there a net dipole for CCl4? Select Yes or No option button to find out. Is there a net dipole for CHCl3? Select Yes or No option button to find out. Is there a net dipole for CH3Cl? Select Yes or No option button to find out. What do you conclude about polyatomic molecules which have no net dipole? Click Next for the answer. Answer. Molecules which have no net dipole moment have a symmetrical distribution of similar atoms. Thus, the dipoles cancel each other. Molecules with no net dipole moment are called nonpolar molecules. When polar molecules are placed in an electric field, they will flip until they lie with their negative ends towards the positive plate and their positive ends towards the negative plate. The illustrative experiment shows the behavior of a polar liquid in the presence of a charged rod. Equal dipoles pointing in opposite directions cancel each other. Polar molecules have dipoles which do not cancel each other. In general, molecules containing a symmetrical distribution of similar atoms are nonpolar. Aluminium oxide, Al2O3, has a high melting point of 2050 degrees Celsius and is insoluble in water. What does this tell you about the bonding in aluminium oxide? Click Next for the answer. Answer. It has both ionic and covalent characteristics. This is because the Al3+ ion formed can attract electrons from the O2- ion as shown. This gives the ionic bond a degree of covalent characteristics. The distortion of the electron cloud of the anion by a neighboring charged ion or dipole is called polarization. The ability of a cation to attract electrons and distort an anion is called its polarizing power. Consider the three ions Na+, Mg2+, and Al3+. Al3+ has the greatest polarizing power of the three ions. In what way is Al3+ different from the other two ions? Click Next for the answer. Answer. Among the three ions, Al3+ is the smallest in size and the most highly charged. The polarizing power of a cation, therefore, depends on its charge density, charge over size. Aluminium oxide, Al2O3, has a higher degree of covalency than aluminium fluoride, AlF3. Why is this so? Answer. The oxide ion is larger in size than the fluoride ion and thus it is more easily polarized. There is, in actual fact, no sharp dividing line between ionic and covalent bonding. Ionic bonding and covalent bonding simply represent the two extremes. Covalent bonds that are polar are said to have partial ionic character. The degree to which a bond is polar can also be referred to as the amount of ionic character of the bond. This varies in a continuous way with changes in the electronegativity difference as shown in the graph above. Click on delta En 1.7 button. A bond with an electronegativity difference of 1.7 is said to have 50% ionic character. The general rule is that when the electronegativity difference is greater than 2.0, the bond is considered to be ionic. Ionic compounds possess a degree of covalency. The distortion of the electron cloud of the anion by a neighboring charged ion or dipole is called polarization. The polarization of an ionic bond and therefore the degree of covalency is high. If the cation is small and highly charged, the anion is large. There is no sharp dividing line between ionic and covalent bonding. Covalent bonds that are more polar are said to have a higher percentage of ionic character.